after the intro with our trig identities, I'm now going to show you how to use them. What I'm going to do is I'm going to verify that these two equations or these two statements are congruent. It's saying sine theta times cotangent theta equals cosine theta. They don't look the same, so I'm going to end up making them look the same. The one downfall or restriction is you can only change one side of our identity. So I've got two harder ones set up here. I can only deal with one side at a time. So using the identities from the previous video, I'm going to use those to verify these statements. Okay? So here, what I'm going to do is I'm going to change this cotangent to cosine over sine. So the sine of theta times cosine theta over sine of theta equals cosine theta. Okay? Typically what I like to do is I like to get everything in terms of sine and cosine because I'm more familiar with those. But any of the identities that we know will work. Some paths just might be shorter than others. So here, now I can see I have a sine divided by sine, so those will reduce out, leaving me with cosine, which indeed does equal cosine. Pretty straightforward with that example, okay? One identity canceled out my sine, I was left with cosine. All right, I haven't done these other two, so you might get to see me struggle a little bit, mental process through these. They're a little bit harder. All right, and if you remember your trig identities, that's also helpful. So, I'm trying to remember this one. So what I'm going to do is I'm going to come back to my original sine squared plus cosine squared equals 1. To get cotangent, I need cosine over sine. So I'm going to go ahead and multiply everything by sine. So that was 1 plus cotangent squared equals cosecant. Okay, so what I'm doing, sorry, I don't have all of my identities memorized, but I do know my sine squared plus cosine squared equals 1. So I use that to help me remember this identity. So I can see here 1 plus cotangent squared, that's right there, that equals cosecant. So I'm going to make that switch. So now I have sine squared times cosecant squared, and I'm still trying to verify that that equals 1. Here, I know that cosecant is the reciprocal of sine, so I am going to now change that to 1 over sine squared. Sine squared divided by sine squared will reduce to 1, leaving me with 1 equals 1. Okay? Without using this trig identity, we could still verify this. It would have just taken me a little bit longer. A few more steps, but all algebra steps. Okay? One more over here. So I have secant theta minus cosine theta divided by secant theta equals sine squared. All right, let's see what I can do with that. All right, let's see. I'm going to go ahead and say I've got 1 over cosine theta minus cosine theta all over 1 over cosine theta. So I switched my secants with the reciprocal cosine. So I'm going to go ahead and make this have a common denominator. So I'm going to multiply this cosine by cosine theta over cosine theta. So in the numerator, I now have 1 minus cosine squared theta over cosine divided by 1 over cosine. So I just had two fractions. I just wanted to combine my two fractions, and to do that, I did a common denominator. We know that algebraically. And now I have a fraction divided by a fraction, so I'm going to multiply by the reciprocal. So now I have cosine divided by cosine, and I have 1 minus cosine squared theta equals sine squared theta. And again, if you remember our trig identity, which is sine squared theta plus cosine squared theta equals 1, if I minus the cosine squared theta from both sides, sine squared theta equals 1 minus cosine squared theta, so I can make that substitution, Sine squared theta equals sine squared theta. Done. Verified. That's it. It is a little bit tricky and it's a little bit like a riddle. Like, where do I start? What do I do? A good starting point is get everything in terms of sine and cosine. Look for the algebra. Do I need to multiply by a conjugate? Do I need a common denominator? Do I need to distribute? All of that comes into play. As long as you know your trig identities, the rest is just basic algebra. Let me know if you have questions. I really love this stuff. Happy to help.